Okay, 7.RP.2.a, this is 7th grade, ratios and proportions, standard 2, subpart A. We are in video 3, and today we're talking about proportional relationships. We're going to be able to decide whether or not two quantities have a proportional relationship, and we're going to be doing that by testing for equivalent ratios in a table or graph. Okay, a few terms to know. I'd like you to copy these down and put them in your journals. All right, first we're going to talk about proportions. And you're going to see some fractions here that are very familiar to you. I started off with 1/2, and the equivalent fraction to 1/2 is 5/10. So if you think about the relationship that you have between your numerator and your denominator of both fractions, you got to think, what did you do to the 1 to get a 5 and the 2 to get a 10? Well, the relationship between the top and the bottom would be you multiplied both the numerator and the denominator by 5. So we would say, well, 1 times 5 is equal to 5, and 2 multiplied by 5 also would get you 10. So the equivalent fraction to 1/2 is 5/10. Well, what do you see in the second proportion? How did you get from 3 to 9 and 4 to 12? Is there any relationship there? Yes, you multiplied by 3. You took 3 times 3 to get 9, and you took 4 multiplied by 3 to get 12. And if you think about it backwards, how do you simplify 9/12? Well, you would divide both sides by 3, and you would end up back at your 3/4. Okay, the third one, I have a variable in there, and you have to, you could do it a couple of ways. You could do it algebraically, which we call that the cross product rule, but I kept some fractions with some lower numbers, and I figured you'd probably be able to think about what that x could be, given the fact that we have a 5 and 25 in the numerator. Okay, so what could x be? All right, so you multiplied 5 by 5 to get 25, and then you probably thought to yourself, well, if I multiplied by 5, that would get me my denominator. So 7 times 5 would get me 35. So your x right here would equal 35, and now we have equivalent fractions, and in this case, since they're equivalent, we also have them to be proportional to each other. All right, and then the bottom one. Bottom one's a little tougher. You see that we actually went downward. We went from 10 to 5 in the denominator. So other than subtracting 5, which we know we can do, when we're talking about proportions, we're talking about division and multiplication. So what could you do to get from 10 to 5? Okay, you divided by 2. So if you took the denominator 10 and you divided it by 2, you got your 5. So what would you do in the numerator? Well, you would take your 6 and also divide it by 2, and you would get x being 3. So x is equal to 3. So these are all proportions, proportional relationships. Your numerator relates to your numerator of the second fraction, and the denominator relates to its denominator also. All right, now according to the standard, it looks like we are going to have to extract some information from tables and graphs. So in the big blue writing there, it says, in order for there to be a proportional relationship between two quantities, that's your x and your y, the graph of the quantities needs to be a straight line through the origin. That's very important to understand, that when we're talking about these proportional relationships, that whatever our table of values are, or the graph that we're looking at, is a straight line, and it goes through 0, 0 on a grid. We've been talking about coordinate planes. So that line must go through the origin. All right, so looking at this table, I picked some very small numbers because I thought it would be easier to think about the small numbers at first. So we have the x and the y. So we have a 1 and a 2, a 2 and a 4, 3 and a 6, and a 4 and 8. Can you think of any relationship that's going on with those numbers right there? You're right. Okay, so all of your x values are being multiplied by 2. 1 times 2 is 2, and 2 times 2 is 4. 3 times 2 is 6, and 4 times 2 is 8. So let's look at that on a grid. If I were to graph all these points, let's do the first ordered pair. We have 1, 2. So we have 0 is the origin, and we have 1, 2, put a dot. And then I have the next relationship of 2, 4. So I go over to 2, and I go up to 4. I have 3, 6. So 0, 1, 2, 3, 2, 4, 6. And then I have 4 and 8. So 4 goes up to 8. Now I'm going to take out a straight edge and graph my line and see where it's going to be going here. All right, let's see here. Sometimes it's hard to make that straight line. All right, I'm just going to keep going all the way downward there for you. And let's extend this out also a little bit. Okay, so if we're talking about proportional relationships and we're following the rules on the last page, what were the two necessary thoughts about proportional relationships? Yes, it needs to be linear, which is a straight line, and it also needs to go right through the origin 0, 0. So if we were to continue this table maybe upwards, what would the number be before 0? I'm sorry, I gave you the answer. What's the number before 1? So the number before 1 is 0. So if x is 0, and I were to multiply it by 2, what is 0 times 2? Okay, so we're at 0. So we have our origin 0, 0 as being one of the points on our table. And you can make some predictions out of this too. So if I were to continue with the 5 or maybe all the way down here to 10, what would the y values be? What would your outputs be if your inputs were those two values? So 5 times 2 would be 10, and 10 times 2 would be 20. And if you're talking about, these numbers are pretty small, but I always think of if you're babysitting and you're working for a certain amount of time, maybe we could have X being the certain amount of hours that you work, and then your output values could be the amount of dollars that you make per hour. Okay, now again, if you think about it, that's kind of a silly thought here, because if you're working for an hour and you're making $2 an hour, I mean, it's time to look for a new job, to be honest with you. So you can have this relationship with time versus money. If we could label our axes here. So this is my x-axis, would be hours worked maybe. And then if we were to label the y-axis, that would be, money that could be earned. So many different types of relationships could be. This is a positive relationship because we know that as your x values are increasing, your y values are also increasing. And as you can see, we have that positive slope. All right, the second example, again, trying to think about this relationship in terms of being a straight line and going through the origin. You're looking to see what relationship do the x and y values have to each other. So I kept the numbers kind of small again. I have 1, 1, 2, 4, 3, 9, and 4, 16. Does anyone see that relationship? Okay, so the relationship isn't multiplying each term, each input by a certain integer. We're actually taking the inputs and we are squaring them. So I'm taking all of the x values and I'm squaring them. So y right now is equal to my x squared values, because if you were to take 1 and square it, you would get 1 times 1. If you were to take 2 and square it, that would be 2 times 2, which is 4. 3 squared, which is 9, and 4 squared, which is 16. So the relationship that we have of our inputs and outputs are that your inputs are being squared to get your outputs. All right, now how does that look on a table? Does this fit our idea of proportional relationships? All right, let me quickly graph this here. We have 1, 1. Now I've already set up your values on your grid. I had a small amount of x values, so I divided up the grid in fourths. So if you're thinking of each of these lines, I have 0, 1/4, 1/2, 3/4, and 1, and I did that all the way across your x-axis. All right, so if I were to go to 1, 1, 1, 1, I have a little graph right here. And on my y-axis, as you can see, I went by 1 full unit each. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, wait a second. 6, 7, 8, 9. I got to move that up. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, glad I caught that. So now we have 1, 1. Our next one is going to be 2, 4. So I go over 2, 1, 2, 3, 4, 3, 9, 3 up to, where's 9? Right there. 4, 16. So we go up 4. There's my 15, and then one more is 16. And I mean, you could continue it if you wanted to see how this picture is going to look. I'm going to work backward again. I'm going to choose that 0 value, and if I were to square 0, that would be 0 times 0. What does that equal to? What would your output be? Okay, so 0, 0, which would be all the way over here at the origin. Now that fits one part of our rule for proportional relationship. Does it fit the linear rule? So I'm going to take out my straight line and I'm going to connect my points. Wait a second. Wait. My points aren't connecting. My points are not connecting in a straight line. What's going on here? Anyone know? Okay, it's not linear. I graphed my points correctly. I checked out all of my ordered pairs, and I have noticed that this is not a linear relationship. I do not have a straight line, so this is not proportional. What it is, and we're going to get more into this when you get into algebra, this is called an exponential equation. So we are going to be actually going on this arc looking pattern. Not linear, okay? In your journal, I'd like you to define the given terms, write a few sentences on what you learned new from this video. Any questions, please write them down. And then in the next video, we're going to be talking more about how these refer to unit rates, and that's going to get us some more graphing, checking out pictures and tables, and we'll do that next time.